Sit down, please. In this section, we will study division of polynomials. Any mth degree polynomial can be divided by any nth degree polynomial provided degree of numerator is greater than that of the denominator. Then division is possible. If that is not the case, that is degree of denominator is greater than degree of numerator, then division is not possible. So all the examples which we are now considering will be of the type polynomial in the numerator has a degree greater than that of the polynomial in the denominator. That is first thing. Now before we go to actual division, let me tell you, when we say that degree of a polynomial is 2, then that polynomial will consist of 3 terms. Coefficients may be anything, but total 3 terms. Meaning is, if polynomial is of nth degree, then how many terms will be there? N plus 1th term. So you must remember this fact while we are studying the division of polynomial, that degree n means n plus 1 terms. 5 terms means degree of the polynomial is 4. Okay. Now we come to actual procedure of division. As I said that there will be one dividend and another will be divisor. In this case, a sutra is applied, and that sutra is paravartya yojayet, transpose and apply. This sutra is operated on a divisor only. So divisor is changed according to this sutra, and then remaining procedure is somewhat similar to what we used to call synthetic division method. We have studied synthetic division method. That method and the procedure applied is not exactly similar, but somewhat we can have some relation with what we have earlier studied as synthetic division method. So to start with, whenever we got a problem, we will decide what is our divisor according to the Paravartya Sutra. We call that modified divisor. For example, if my divisor is ax plus b, then my digit of the divisor will be minus b upon a. Paravartya means transpose. If it is plus, then minus. So paravartya yojayet means if divisor is ax plus b, then digit of the divisor is minus b upon a. If divisor is ax square plus bx plus c, then divisor will consist of the digits minus b upon a minus c upon a, and the procedure will go. Let us come to the first example so that the things will be clear. Example is divide 3x cube minus 2x square minus 24x plus 9 by x minus 3. We observe that our divisor is x minus 3. So modified divisor will have a digit. We start with minus. To transpose it, we take minus 3 as it is and coefficient of x, that is highest degree term. So we get minus of minus 3 upon 1, that is 3. So whenever divisor is x minus 3, modified divisor or digit of the divisor is only 3. Now we write the structure. First we write the terms x cube, x square, x, c means constant. Then we write the corresponding coefficients 3, minus 2, minus 24 and 9. The first vertical line, and then we write the divisor. This is the structure to be followed every time. Write the coefficients of the dividend and one vertical left line to extreme left and write the divisor 3. Once this is done, now the procedure of division starts. Step number 1. The first digit 3 as it is, no change. Whatever digit is there, we keep that. Then this 3 of the divisor multiplied by 3, 3 into 3, 9 is to be written in the next right column. 3 into 3, 9, we write in the next right column. Then addition, minus 2 plus 9, 7. 3 into 7, 21, we write in the third column, that is column of coefficients of x. Then addition again, minus 24 plus 21 is minus 3. 3 into minus 3, 3 means our divisor always. 3 into minus 3, minus 9, we write in the last column in this case, that is column of a constant. Again addition, 9 minus 9 equal to 0. So this completes the arithmetic part of the division. We started with divisor 3 and we perform the calculations by the said procedure. Now, which is the quotient of the division? What is the remainder of the division? That is the most important part, because division is completed, okay, but answer should be this is quotient of the division and this is remainder of the division. Now this line, second vertical line, decides how many digits will be there in the remainder. How to fix that line? Now we know the rule that degree of the quotient always is equal to degree of the dividend minus degree of the divisor. If I got a polynomial of 5 degree in numerator and a polynomial of 3 degree in the denominator, naturally quotient will be polynomial of degree 2, 5 minus 3. Exactly same idea, degree of quotient is degree of dividend minus degree of divisor. Here degree of dividend is 3 because highest degree term is cube term. Degree of divisor, highest degree term is 1. So we get 3 minus 1 equal to 2. Degree of the quotient 2 means quotient will consist of 3 terms. Okay. Then decision about the degree of remainder. Degree of remainder is equal to degree of divisor minus 1. So here we get 1 minus 1 equal to 0. Degree of remainder 0 means how many terms? 1 term. So we write vertical line which separates the answers 3, 7, minus 3, 0 are 4 digits in the answer. We draw a vertical line after 1 term because degree of remainder is 0 means remainder will consist of how many terms? 1 term. This is a theoretical part. In practice, this can be very easily decided. If our modified divisor consists of 1 digit, we will draw a vertical line which separates quotient and remainder after 1 digit counting from right. You can see this example. Here there are 2 digits, so we have drawn a remainder line after 2 digits as counted from the right. So in practice, this theoretical rule of deciding a degree of quotient and degree of remainder can be very easily tackled by counting the number of digits of the modified divisor and then drawing a line. Answer is quotient has 3 digits, 3, 7, minus 3 and 2 degree. So what is the answer? 3x square plus 7x minus 3. Degree 2, 3 terms, 3x square first term, 7x second term and minus 3 constant. Remainder is 0, quantitatively 0, term 1. Okay. So final answer of the division is quotient is 3x square plus 7x minus 3, remainder 0. Now we come to the next. Second example. Second example is divide 6x to the power 4 plus 5x cube minus 2x square plus 7x minus 3 by 2x minus 1. So let us note the difference. In earlier case, divisor has a coefficient 1. Highest degree term has a coefficient 1. Here highest degree term has 2. So modified divisor will be minus of minus 1 divided by 2. Okay, that is 1 upon 2. That 1 upon 2 we write at the divisor place of the structure. Then we write the term 6x to the power 4, then 5x cube minus 2x square, 7x and minus 3, which is a constant of the dividend. We start numerical part of the problem. First digit 6 as it is. Then 1 upon 2 into 6, 3 is to be written in the next right column. 5 plus 3, 8. Then 1 upon 2 into 8, 4. We write in the next column. Minus 2 plus 4, 2. Then 1 upon 2 into 2, 1. 7 plus 1, 8. 1 upon 2 into 8, 4. Minus 3 plus 4, 1. So numerical part is over. Now we draw a remainder line. Again the same rule. Divisor has only one digit. So we draw a remainder line after one digit counted from the right. So my quotient will consist of 4 digits, 6, 8, 2, 8, and remainder will consist of one digit, that is 1. Now a very important step. As I note earlier that here highest degree term has coefficient 2. That 2 is to be taken care of while writing the answer. We have not divided by 2 numerically, we have divided by 1 by 2. That is why while writing the answer of the quotient q is equal to, we start with 1 upon 2 times 6x cube plus 8x square plus 2x plus 8. That is 3x cube plus 4x square plus x plus 4, and remainder equal to 1. Yes?
So if we have ax square plus bx plus c, so in that case we will be dividing the quotient by a.
Yes, every time. While writing the quotient, if the divisor is ax square plus bx plus c, we will start with 1 upon a times the answers of the digits. That rule is to be always followed. Okay?
So like here the divisor is a fraction.
Yes.
Yes, sir. So if the number to be divided is not divisible by it, so then what do we do?
Then we will take the fraction.
So that is if
Okay, just see. If instead of 8, I get 7, I will get 7 by 2 here. And then I will add minus 2 plus 7 by 2. Now we come to example number 3. Here divide x to the power 4 plus 2x cube plus 7x square minus 5x plus 4, and divisor is x square plus 2x minus 1. Observe that no term is missing, every term is present. So we write digits of the modified divisor as minus 2 upon 1. Do you follow how I get 2 upon 1? 2 coefficient of x divided by coefficient of highest degree term 1. So first digit is minus 2. Second digit will be minus of minus 1 divided by 1 equal to 1. So we get 2 digits now. We write them in the same order. We don't reverse the order. First digit minus 2, then second digit. We write the dividend x to the power 4, 2x cube, 7x square, minus 5x and constant 4. We start the numerical calculations. 1 as it is. Okay. Now minus 2 into 1 minus 2 is written in the second column, I call it, and 1 into 1 equal to 1 in the third column. The similar procedure to this. Here there are 2 digits in the divisor. So we start minus 2 into 1 minus 2 in the second column and 1 into 1 equal to 1 in the third column. Okay. So this multiplication, divisor and the digit, is to be carried out simultaneously in 2 columns. Okay. Now we add 2 plus minus 2 equal to 0. Next, minus 2 into 0 equal to 0 in the third column and 1 into 0 equal to 0 in the column number 4. We add digits of column number 3. 7 plus 1, 8. Again we start the multiplication. Minus 2 into 8, minus 16. 1 into 8, 8. Then minus 5 plus minus 16 is minus 21 and 4 plus 8, 12. We discontinue because we come up to the constant degree term. Now we draw a remainder line. As I said, there are 2 digits in the divisor. We draw a remainder line after 2 digits as counted from the right. We can check this by our regular method. Degree of quotient is degree of dividend minus degree of divisor, and degree of remainder is degree of divisor minus 1. The rule holds here also. Now the quotient. Because highest degree term of the divisor has coefficient 1, we started with 1 into 3 terms, 108 means x square plus 0x plus 8. So quotient is equal to x square plus 8. Remainder 2 terms, minus 21 and 12, 2 digits we have. So remainder is to be written minus 21x plus 12. So division gives the answer quotient x square plus 2, remainder minus 21x plus 12. Let us see what is the next example. 9x to the power 5 plus 12x to the power 4 minus 6x cube minus x square minus 45x plus 7. Divide this polynomial by 3x square plus 6x minus 1. Now let us decide the digits of the divisor. Come on. First one.
It will be minus b by a,
yes,
that is minus 6 by 3
minus 6 upon 3, that is minus 2. First divisor, first digit. And what is the second digit?
Second is minus of c by a, that will be minus of minus 1 by 3.
Yes,
that is, 1
that is
by
equal
3.
to 1 upon 3. So we write minus 2 and 1 upon 3 in the divisor line. Again I repeat, don't change the order. If you write 1 by 3 first and minus 2 then every calculation will go wrong. Now we start the calculation.
The 9 as it is.
9 as it is.
9
Yes.
into minus 2.
9 into minus 2.
That is in second column.
Minus 18. Minus 18 in the second column. Then
9 into 1 by 3.
9 into 1 by
that
3.
Is,
3 in the
third column.
Yes.
So then 12 and minus 18 gives minus 6.
Minus 6. Addition gives minus 6.
Yes,
Minus 6.
Minus
Yes.
2 is multiplied by minus 6.
6.
12.
12.
Third column.
Third column.
Yes, sir.
Then
And 1 by 3 is multiplied by
1 by
minus
3
6
into minus 6
gives
minus 2 in the fourth column. Yes.
So then we'll add minus 6 plus 3 and 12.
Plus 12. Okay. Minus 6 plus 3
Plus 3 and
plus
plus
12.
we'll
That
get
gives
9.
9. Next.
So 9 into minus 2
9 into minus 2
is minus 18.
minus 18 in the fourth column.
The fourth column.
Yes.
And 9 into 1 upon
1
3
upon 3
is 3
3
in the fifth column.
in the fifth column.
Then we add fourth column minus 1,
Huh.
minus 2, minus 18,
Minus
and
18. Minus
21
1 plus minus 2 plus minus 18.
is
That
minus
gives
21.
minus 21. Okay. Next.
So then minus 21 into minus 2,
Yes.
42.
42 in the fifth column.
column.
Yes.
And then the result, then minus 21 into 1 by 3.
Yes.
Minus 7 in the,
In the
last
sixth column, last column.
Yes, sir.
Now once we reach the last column, we discontinue the procedure. Now we add minus 45 plus 3 plus 42, 0, and 7 plus minus 7, 0. How to draw a remainder line? Yes.
So we have two divisors.
Two digits in the divisor. Yes.
So
We draw the line.
remainder line from right to left. by
After
selecting two
how many
columns.
digits?
So two
After
columns.
2 columns or after 2 digits.
Yes.
Okay. So that remainder line is drawn. We observe that quotient has 4 digits, 9, minus 6, 9 and minus 21, and remainder has 2 digits, 0 and 0. Okay. We start writing quotient. Again observe that highest degree term of the divisor has coefficient 3. We start writing quotient q equal to 1 upon 3 times. Why this should happen? See, 9x to the power 5 is the highest degree term of the dividend, and 3x square is the highest term of the divisor. So if I normally divide 9x to the power 5 by 3x square, how much I will get? 3x cubed and not 9. So that is adjusted by writing 1 upon 3 here. So 1 upon 3 times. Now 4 terms means degree of the quotient 3. So we start 1 upon 3 times 9x cube minus 6x square plus 9x minus 21, that is 3x cube minus 2x square plus 3x minus 7. Now remainder 0x plus 0. So final answer is quotient is 3x cube minus 2x square plus 3x minus 7, and remainder is 0x plus 0. Now we come to the example number 5. 16x cube minus 2x square plus 5x minus 3 divided by 4x square plus 1. First thing which we note in this case that divisor is 4x square plus 1. So one term which is in x is missing. That missing term is to be inserted by writing coefficient 0. If the constant term is missing, if I have a 4x square plus 7x only, I would have write 4x square plus 7x plus 0. So digits of the divisor now are minus of
Minus of 0 by 4. That
0
is
upon 4, that is 0. Yes.
The other is
Minus of 1 upon 4. If you don't, that is minus 1 upon 4. If you don't take this 0, then you will get one digit in the divisor and whole thing will go. So be very careful about that. Now we write x cube, x square, x and 0. Can you tell me the dividend?
The dividend is
16x cube minus 2x square plus 5x and minus 3. How many digits? 0 and minus 1 by 4 are written here. So what is the first step? 16 as it is. Yes. Second step?
16 is multiplied by the first digit,
0.
that is 0. So we get 0 in the second
column. Yes.
Then again 16 into minus 1 by 4.
Yes.
Minus 4 in the third column.
Third column. Next.
Sir, we add the second column.
Yes, we add the second column.
We get minus 2 plus 0 is minus 2.
Minus 2.
Then minus 2 into 0 in the third column.
0.
0.
Minus 2 into 0 is 0, in the third column.
Third column. And minus 2 into minus 1 upon 4. That is 1 upon 2.
1 upon
in
2.
the fifth column.
So even if fraction appears, it is not necessary that every time you will get all the digits divided by the divisor. So minus 1 upon 4 into minus 2, we get 1 upon 2. So write whatever we get. Then the procedure is over because we reach up to the constant term. Now we add 5 minus 4 equal to 1 and minus 3 plus 1 upon 2 equal to minus 5 by 2. So quotient is 1 upon 4 because highest degree term has 4. 1 upon 4 into 16x minus 2 that is equal to 4x minus 1 upon 2. Remainder has 2 digits, 1 and minus 5 by 2. So remainder will be x minus 5 by 2. So what we observe from this is the numerical procedure remains similar to synthetic division, but 2 or 3 things are to be noted. You must note the divisor. If any term is missing, insert it. Then decide the digits of the divisor. Write the digits of the divisor exactly in that order in which we get, and then numerical procedure. Remainder line is to be fixed first, and then write the quotient, then write the remainder. So what is new here? New thing is, in practice, the synthetic division method is applicable only when the divisor is ax plus b. Here that restriction is removed, and that is the contribution, you can say, of Vedic mathematics to our mathematics. Have you followed everything? Yes. Thank you very much.